Hello friends, let's talk about a utility maximization problem. The question is, Tanya's utility function is U equals to 10 Q1 square Q2. In Gurugram, Haryana, Tanya's income would equal to rupees 600 and the prices of good 1 and good 2 are rupees 5 for each. In Bangalore, Tanya's income would equal to rupees 1020 and the prices of good 1 and good 2 are rupees 8 and rupees 10 respectively. First part says, what is Tanya's budget constraint if she lives in Gurugram? So this is how we solve. Utility function is this. Income is rupees 600. P1 is rupees 5 and P2 is rupees 5. So the budget constraint is given by Px into x, the price of good x into the quantity of x, plus the price of good y into quantity of good y should be less than or equal to your income. So 5Q1 plus 5Q2 should be less than or equal to 600. Correct? We don't know Q1 and Q2. Right? Second question says, what is Tanya's budget constraint if she lives in Bangalore? Now in this case, we just substitute the values of P1 and P2 as given respectively 8 and 10. That's the only thing that changes. And the income, which should be less than, so 8Q1 plus 10Q2 should be less than or equal to 1020. This one is the main equation in which we just substitute the values of P1 and P2 and income in order to have a budget constraint respectively in two cities. Alright. Third part says, compute the MRS equation using Tanya's utility function. MRS equation is given by MRS for xy equals to change in y by change in x, which is nothing but derivation of utility function with respect to x, derivation of utility function with respect to y, which is nothing but marginal utility of x divided by marginal utility of y. Therefore, given your equation this, the marginal utility of good 1 will be given by derivating your utility function with respect to Q1. So this is the derivation with respect to Q1. We keep Q2 as constant. So 100 to Q1, Q2. So that's 200, Q1, Q2. And MU2 is given by the derivation of utility function with respect to Q2. So that is just 100 Q1 square. Therefore, your MRS equation for good 1, good 2 is MU1 divided by MU2. So, given this, 200 Q1 Q2 divided by 100 Q1 square. Now, which after all the cancellations, which come down to 2Q2 divided by Q1. Alright, so this is your MRS equation. Now in part 4, it says that find Tanya's optimal consumption of X and Y if she moves to Gurugram. Now in order to know the optimal consumption of X and Y, the law of equimarginal utility would hold true, or the MRS equation. It's the same thing, right? So MRS of XY should be equal to Px by Py. Either this should hold, and if we just rearrange this, so MRS of xy is nothing but MUX divided by MUY, which is equal to PX PY. Now rearranging all this, we get MUX by PX equals to MUY by PY, or since we have good 1, good 2, so I just write 1 and 2 instead of x and y. Correct? This is nothing but your equimarginal law, equimarginal utility law, and this is nothing but an equation that gives you the optimal consumption of x and y. So rearranging this, we get this law. Correct? So now we just substitute the values. 200 mu1 is 200 q1 q2 divided by p1, that's 5 in case of Gurugram, and mu2 is 100 q1 squared divided by 5, that's p2 in Gurugram, the price of good 2 in Gurugram, right? So cross multiplying each, we get this equals to this. Then I find the value of Q2 basically. So after all these cancellations, I bring all this whole thing down, and after all the cancellations, I get 2Q2 equals to Q1. Now we insert the value of Q1 in the budget constraint of Tanya in Gurugram. So by doing so, the budget constraint was given by 5Q1 plus 5Q2 equals to 600. So I just substitute the value of Q1 from here, which is 2Q2. 2Q2 plus 5Q2 equals to 600. 10Q2 plus 5Q2 equals 600. So 15Q2 equals 600. So basically your Q2 equals to 600 divided by 15, which is 40 units. Since now we have got the value of Q2 as 40 units, I just substitute that value in my earlier equation, which was this Q1 equals to 2Q2. So instead of Q2, I substitute the value of 40. So 2 into 40, that's 80 units. So in Gurugram, Tanya will be consuming Q1 of 80 units and Q2 40 units. This is our optimal consumption bundle. Okay. Now in the fifth part, we find the value of Tanya's optimal consumption of X and Y if she moves to Bangalore. So we use the same method as in part 4, and we get this divided mu1 divided by p1 equals to mu2 divided by p2. mu1 and mu2 remains the same. What changes is your price of good 1 and price of good 2 in Bangalore. So price of good 1 was given by 8, price of good 2 is 10. And again, just cross multiplying and rearranging, we get Q2 equals to all this. So this into this, that comes in the numerator, this into this, that comes in the denominator, Q2 remains here. And after all the cancellations, I get Q2 equals to 0.4 Q1. Alright, now let's move forward. Now we substitute the value of Q2 in the budget constraint of Tanya in Bangalore. So 8Q1 plus 10Q2 equals to 1020. So 8Q1 plus 10Q2 is 0.4 Q1, which is equal to 1020. Then 8Q1 plus 4Q1, 10 into 0.4 gives me 4 equals to 1020. So that's 12Q1 equals to 1020, and Q1 is 1020 divided by 12, which gives me an answer of 85 units. Now again, similar way, substituting the value of 85 units in this equation, Q2 equals to 0.4 Q1. I get Q2 as 0.4 into 85 equals to 34 units. Therefore, in Bangalore, the optimal consumption of good 1 is 85 units and Q2 is 34 units. Now, sixth part says, which location does Tanya prefer to live? Explain briefly how you can tell. Now, we checked for MRS of X and Y for both places. Gurugram, we get this. It means how many units of Y a person is willing to give up in order to obtain 1 extra unit of X. Okay, thank you and see you next time.